is to record. Yes, now, yes, I can. Yeah. Yeah, as yeah, insulator, you can see here alumina, the name of the insulator we posted here. I mean, there are a lot of even the polymers, plastic, wood, etc. They have a conductivity very low, and they have this value should be very large and positive. Here ions, but insulators. One of the example is dielectric material also. The dielectric material can give the response in the presence of electric field. So now we completely summarize the metal semiconductor insulator. Moving into the what are the semiconductors? As I already discussed this, if the energy gap is more, if the energy gap is more than the around 6 electron volts, we call it insulator. And the top panel is conduction band, bottom panel is valency band, middle one is energy gap. If the energy gap is lower, we call it semiconductor, which is about 1 electron volts. If the bands overlap, if they అంటే రెండు కలిసిపోతే, if they overlap, so you have the plenty of electrons move from the valence band to conduction band. So here only charge carriers are the electrons. Here you have the holes in electron, because when electron jumps from the valency band to conduction band, there is a space left, which we call it as the holes. In resistance, as I already mentioned, that resistivity can be represented units ohm meter, which is the order of 25. uh, for metals, it is going to be very less. This is a competitive exam bit better. Competitive exam lo adugutar MSc vaatlo. So resistivity should be very low for metals, very low for metals. Okay, let me keep this. Give me 1 second. Hold on. Let me use my digital pad so that I can write it. Yeah, you can see here very low limits for metals, 10 power minus 6. When you are moving to the semiconductors, it's going to be 10 power minus 3 minus 1. Even the it's more than the around 1002 silicon. So for semiconductor, resistivity increases. For metal, it's a very less. And the formula we use this one: R is equal to rho L by A. Rho is the resistivity and R is the resistance. And they're going to use, definitely they're going to ask problem based on this relation between the resistance, sorry, resistance called resistivity L by A. Here L is the length of the conductor, A is the cross sectional area, R is the resistance, rho is the resistivity. So you should remember those values. I mean those names. Moving into the uh, I mean, you can also remember this with, for insulator. In the previous slide, we did to show the insulator. For insulator, it's a really, really very high resistance. You can see semiconductor itself, like semiconductors. It's less than. It should be like maximum 10 power 3. But here you can see glass is also insulator. I can see some people are in the waiting room. I can just yeah. These are the insulator: SiO2, Al2O3, PVC, polymer, mica, rubber, diamond. See, diamond also is best insulator, but it still show the conductivity. I'm gonna discuss this later. Okay. Okay, let me go for the, we discussed now resistivity for all the material. Now moving into the band, already discussed, I don't want to discuss again, semiconductors. What are the semiconductors? Semiconductors over the material, I can see, okay, semiconductors over the material. Please take the screenshot. One of you take the screenshot of attendance so that I can you know, I mean, I can also post the attendance link in the chat box later. Remind me after 5 minutes, I can post it based on the step, so that you can enter your details. I'll drop those details when you are coming for attendance, when you're coming for the practical exams. You will see definitely, attendance makes very important, and the university stated very serious, instruction. If the students have are not attending online classes, you can issue the TC for them. So they have instructed for us. So be careful, guys. You have to attend every day classes. Otherwise, you are not going to get a ticket for the exams. Especially, we are also not going to give the marks for the practical exams too. So please attend classes, and which is useful for you. We are not forcing you to attend. It's your life. It's your life. So semiconductors. Semiconductors are classified into intrinsic semiconductor, extrinsic semiconductors. So intrinsic means very pure conductor. We are not adding any impurities. Okay, so completely germanium silicon. We don't add anything here. So which means number of electrons must be equal to number of holes. సో ఎన్నైతే మనకు ఈ బ్యాండ్ థియరీ ఉంది కదా, వ్యాలెన్సీ బ్యాండ్ ఇది, కండక్షన్ బ్యాండ్ ఇది. ఎన్నైతే ఎలక్ట్రాన్స్ వ్యాలెన్సీ బ్యాండ్ నుంచి కండక్షన్ బ్యాండ్లోకి వెళ్తాయో, సో అక్కడ ఎన్ని ఎలక్ట్రాన్లు వెళ్తే అన్ని హోల్స్ ఇక్కడ ఉంటాయి. సో నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ మస్ట్ బి ఈక్వల్ టు నెంబర్ ఆఫ్ హోల్స్ ఇన్ ద వ్యాలెన్సీ బ్యాండ్. So in that case, the densities are equal. The density of electrons and holes are equal. Okay. So this is called intrinsic semiconductors. Intrinsic semiconductors. How about uh, how about extrinsic semiconductor? Extrinsic means meaning itself. You have to add some impurities. Better. You have to add some impurities. So what are the impurities that we don't understand? Impurity means better. It's not. Don't think about impurity means something else. Impurity ante something you are adding to increase the conductivity of the pure semiconductors. ఎందుకు impurities add చేస్తాం చెప్పండి? To increase the conductivity, to increase the conductivity. ఎందుకు ఇంక్రీజ్ చేయాలి సార్ కండక్టివిటీ అంటే, వెన్ యూ హ్యావ్ ద హయ్యర్ కండక్టివిటీ వి యూజ్ దట్ మెటీరియల్ ఫర్ మేకింగ్ ద ఫ్లెక్సిబుల్ టీవీస్, ఫ్లెక్సిబుల్ టీవీస్, ల్యాప్టాప్లు, ఫోన్లు, ఇవన్నీ కూడా రోల్ చేయొచ్చు బెటర్ అంటే. సో దిస్ ఈజ్ వెరీ ఇంపార్టెంట్. సో వై వి యాడ్ ఇంప్యూరిటీస్? వి యాడ్ ద ఇంప్యూరిటీస్ టు ఇంక్రీజ్ ద conductivity. Very good. So now we understood the differences between the intrinsic and extrinsic semiconductor. Intrinsic semiconductor conductivity is very low compared to the extrinsic semiconductors. Intrinsic semiconductor, we don't add any impurities, so conductivity is lower. Here we add the impurities, we get the conductivity more. Okay, very good. Then moving into the there are two types of extrinsic semiconductors. One is N type, the other one is P type. What are these, sir? So these are the N type is the semiconductor which comes from the extrinsic, and here we add the fifth group element. Here we add the third group element as a impurities, impurities. So when we add the impurities, we're going to get N type. What type of impurities you have to add to get N type? Fifth group element. Someone ask you in some questions come in competitive exam, what are the impurities that we add to get the N type semiconductor? We add the fifth group element. What are those? Phosphorus, antimony, bismuth, arsenic. These are the examples to which we add the as a impurities to get the N type. So how about P type? P-type, to get a P-type, A group elements you add chala, third group elements we have to add it. So what are the elements, third group element? Gallium, boron, indium, aluminum. So these are the elements that we add to the pure semiconductor like silicon and germanium to get P-type semiconductor. In P-type, definitely what you can think about it, P-type means definitely holes are the majority carrier. N-type means electrons are the majority charge carrier. You can see here. Why, sir? You already know this. When I add the fifth group element, germanium is the four valency. Fourth group means four valency electrons. So this, when you add the fifth group elements to the this pure germanium, so five electrons are attached here. One is extra. So one electron is there. Similarly, you have a millions of electrons are there. When you take the material, it's not one electron, right? Many millions. So similarly, you have a more electrons are present here. So majority charge carriers are electrons. Here, you see what happened. Germanium require four, as it is for valency four. We are adding third group elements, which means only three electrons pair with it. Here one, here one, here one. One hole is there here, no electron is there. So for that, so holes are the majority charge carriers in p-type. So now we understood that n-type semiconductors, so n-type semiconductors have more majority charge carriers are the electrons. P-type semiconductor majority carriers are the holes. So electrical conductivity happen in this due to electrons. In this electrical conductivity, happen due to the holes. So this is what you have to remember. What are the, here the impurities are fifth group element, here the impurities are third group element, here the examples are phosphorus, arsenic, antimony, here boron, aluminum, gallium, indium. So I think this is enough for the information. So moving into the, so as you can see here, as you can see, uh, P-type, this is the P-type and this is the N-type. So in case of P-type, more electrons fill in the valency band. See, valency band partially filled. In this case, N-type, you can see electrons in the conduction band too. Here you don't have the no electrons here. No electrons. It's completely empty. It's completely empty. In case of N-type, electrons moved from the valency band to conduction band. So it partially filled in the conduction band. Here P-type, you don't have any electrons filled in the P-type. So this is this in this material conductivity is due to only holes because no electrons present in the conduction band. But here there are electrons present in the conduction band and holes present in the valence band. So conductivity is due to the both electrons and holes, but majority charge carriers here is electrons. Here holes. You can see here I have shown here. This is aluminum for p-type. Right? It has only three, but one is it required it, so it's a hole is created here. Here phosphorus is the fifth group element. Four connected with the silicon. One extra it has electron, and you have more electron due to many atoms present in the material. Okay. So moving into the, let me clear any doubts, Peter? Students, you should respond, please. I don't want to be like class like this. I am teaching, you are listening. It should be like, interactive. You should ask me, sir, can you stop here? Please explain this. Okay, so please, all of you, my suggestion to you, interact with me. And moving into here, you can think about P-type material. This is a P-type material, beta. And here, you can see how do we know this P-type material? Like here, you take the material and connect it to the battery. Okay. Then in P-type material, as we discuss, more holes are there. More holes are there compared to electrons. Okay. The majority charge carriers are the holes. Okay. And when you apply the electric field from the battery, so this is the flow, the electrons, flowing from here. Okay, but holes can go this direction because positive ions, they want to try to go to the negative electron want to go this direction, holes want to go this direction. Why? Because electron want to attract to the positive electrode, holes basically move from the this place to the negative electrode because they are positive ions. So if the ions are positive, they go to the negative electrode. If the ions are negative, they go to the positive electrode. So this is what you have to understand. Any doubts here? One of you always respond to me so that I cannot. Otherwise, I will go like anything. I don't know where I am going also. Okay. Here it's a very interesting beta. You can see this picture. All these are the aluminum. This is the what aluminum means. We can think about it, which group? Third group element. So when I add third group means definitely I would think about this p-type material. P-type means third group element, right? Holes are the majority carriers. Aluminum, see, you can see all the positive are the holes. Okay, P-type. Coming to the so thermal generation, we call it this. Holes, these are the holes, and these electrons are the minority carrier. Very one we have shown here. And acceptor ions, we call it as a acceptor ion. And here you can see that this is like a n type. This is n type. So n type basically fifth group element. Fifth group elements, antimony. You have more electrons here compared to the more electrons. So don't confuse here. Sir, here you kept to positive, here you kept. So I'm talking about electrons, valence electron. Antimony, bismuth, maybe one electron it lost. So I'm focusing only on the electron. So even though it's a antimony, bismuth, when you lose something, definitely it's become negative, right? So I'm just talking about the negative ions. So this is n-type. So n-type or the majority charge carriers are electrons, p-type majority charge carriers are holes. Can anyone, post the, can anyone take the screenshot and post in the group? Only one person, please don't post so many things. I want to see the, I think now it's 31 members present, which is good for me at least today. Very good. Thank you so much for other volunteers who helped to increase the strength. But again, out of 31, 5 members from the Ibrahimpatnam. So that doesn't matter, but still it's better. So junction, how PN junction formed? Ela form avutundi PN junction anedi. You can see some kind of here video. Let me clear it. Oh, you can see there is animation here. So what is going on? Tell me here. How junction is forming? There is a P type and there is a N type is there. Okay. P type means we have a number of holes, majority carrier. N region means we have majority charge carriers or electrons. So when you connect the P and N, combine it. When you combine it, P and N type, you get a PN junction. Okay, we get a PN junction. Like means it's a you are adding, you are attaching the two materials. One is P type, the other one is N type. You are attaching together, and there is a junction formation is there where you don't have the charge. Junction is the one where you have the net charge is zero. There are charge carriers, but net charge is zero. Okay. Here you can see that when you connect this to the battery, the electrons are moving from the negative terminal to the p region, because the p region is the positive. Like let me go for the explain this. So electrons basically go from this region to this region because here negative, right? All they want to go here. Here this side is all positive volts. So one side is positive, the other side is negative completely. So here this region net charge is equal to zero. Okay. So when you connect, this is actually your forward bias, and there are two biases, forward bias and reverse bias. So P is connected to positive, N is connected to the negative. What bias we call it? Forward bias. What bias we call it? Forward bias. Okay. In the forward bias, this junction becomes what happened? This junction becomes, its width becomes decreases. So the junction width, this becomes decreases. Why, sir? Because these p region holes, they move to this side, electrons moves from the n region to the p region. As a result, finally this width decreases. The depletion region, we call it as a depletion region, and the width of the depletion region decreases in the forward bias. When you connect them reverse bias, which is negative here, positive here, what happen? Holes can come to this side, electron comes to this side, this width becomes increases. The depletion, width of the depletion region increases in case of reverse bias. In forward bias, they will ask question. I'm sure they're going to ask questions. In competitive exams, definitely there is a question from the what happened the width of the depletion region in reverse bias? You should answer it increases. What happened width of the depletion region in case of forward bias? Decreases. Why it decreases? Because the holes can diffuse into N region, and electron can diffuse into P region. As a result, the width decreases. But in case of reverse bias, P connected to the negative, N connected to the positive. So P region means all holes basically try to come this side because negative is here. Electron comes to this side, positive is here. And as a result, this width becomes increases. Okay. In reverse bias, basically the width becomes increases. So they're going to ask question like this. What is the, in which bias the current is more? Definitely forward bias beta, because the width decreases, diffusion is more from this side to this side, from this side. So current is more. Current is more in forward bias. Current is less in reverse bias. And current is, here milliamps, here microamps. In the reverse bias, its kind of order is micro bias. So moving into the next slide, we don't have much time. We have only 4 minutes left. I am going to, I am going to, uh, I'm going to post attendance first, then come back here. I don't want you to lose attendance. I'll post now attendance. I'll post now here attendance link. Please fill the details. I just posted. Okay, I have to post all. I think only one person got it. everyone. Uh, can anyone give the response? Did you receive it?
Yes, sir.
Yeah, please fill it. Let me complete the my yeah. We have only 3 minutes, beta. Do you have any questions to discuss, please? Did you understand forward bias, reverse bias, N type, P type, intrinsic, extrinsic? We have summarized, and there are two types of semiconductors: intrinsic and extrinsic. Intrinsic semiconductors are the fused semiconductors. Extrinsic semiconductors are the doped. We have to add some impurities. And extrinsic semiconductor classified into two types: N type and P type. So N type semiconductors are made when you dope the fifth group elements, you get the N type. When you dope the third group element to the third group elements to the pure semiconductors, you get the P type semiconductors. So there are electrons are the majority charge carriers in P type. Electrons are the majority charge carriers in N type semiconductors. And again, there are junction PN junction formation. In PN junction formation, there are two bias: forward bias and reverse bias. In forward bias, current is more; it should be milliamps. In reverse bias, current is less; it should be micro amps. And basically in forward bias, basically holes diffuse into the n side, electron diffuse into p side, and as a result region width decreases. In case of reverse bias, the depletion region width increases due to the holes and electrons go away from the depletion region. So that is a summary of the class. You can also see here again what is depletion region, everything. And next we are going to discuss conductivity. This is a very important question too, 4 marks. Conductivity in semiconductors. So we will discuss tomorrow conductivity, how conductivity changes when we apply the electric field, when you don't apply the electric field. And we're going to discuss the in the presence of electric field, in the absence of electric field. We can also discuss the drift current, how it helps. We can also discuss the whole drift. What is the holes current? What is the electrical current? The total current should be sum of that both. And we can also, this is a very important long answer. Sometimes they can ask, current density, Hall effect, and definitely we'll discuss tomorrow class more. So thank you so much, students, and thank you to all the students who acted as a volunteer to increase the strength. And thank you for the student who joined today as a first class. And you should definitely join every day in order to be attendance, and also it helps a lot for your career. I'll definitely motivate you. I'll give you a lot of suggestions. I think time is less than 1 minute. I don't want to speak anything. Thank you so much. Have a wonderful day. So you can join tomorrow too. Thank you.